In example 5, we need to solve triangle PDA if, let's see, this is an unknown side, is equal to 22 and the measure of angle D is 95 and the measure of angle A is 15 degrees. So let me take a quick look at my notes and we'll see what that side is, and that should be side P, I think. Hopefully that agrees with the notes that you have at home. If there's something different here, let's just make P equal 22. As we draw our triangle, let's make this P and D and A. So angle D here is 95 degrees. Angle A is 15 degrees. And we know that P here is 22. This is an angle side angle. It's not angle side side or side side angle. So we don't have to worry about that whole 0, 1, or 2 possible solutions and checking out each case. We know there's only going to be one solution here. The law of sines might be tough right now. To use the law of sines, we need to have at least an angle on its opposite side. And we really don't have that here. We're missing an angle there. And then we have a side here. You can definitely use the law of cosines, but in this case, what I think might be a little bit easier is to just see if we can figure out what angle P is, and then we'll have that relationship that we can use in the law of sines. So we know that 180 degrees, we subtract 95 and 15, that should give us the measure of the other angle, that's 70 degrees. And all three of those should add up to 180. It doesn't have to be a right triangle, right? All those have to add up to 180, so you can always use that. We definitely don't have a right triangle, so we can't use the Pythagorean theorem, and we also can't use our regular sine, cosine, and tangent. We can use the law of sines though. So if we set up the law of sines here, let's solve for side D first. So we have D over the sine of the angle D, which is 95, and then we have our angle P and side P. Remember that the sides have to go in the same position. In this case they're in the numerator, and then the sine of the angle will go in the other position. In this case it's in the denominator. So if we solve for D, we just have to multiply by sine of 95 on each side. So D will be equal to 22 sine of 95 over the sine of 70. Let's see what our calculator gives us. It's a good idea just to check your mode real quick. And we are in degree mode. We're using degrees, so we got to be in degree mode. So it's going to be 22 sine of 95 divided by sine of 70. And we get about 23.3. So D is about 23.3. The only other missing side we have is going to be off of angle A. So I want you to see how similar this is. I want you to see how similar this is with this original proportion that we wrote over here. So this is A over sine of 15 degrees, and that's going to be equal to 22 over the sine of 70. Oops, that's a 70. And then when we solve this by multiplying by sine of 15 degrees on each side, we'll have A is equal to 22 sine of 15 degrees over the sine of 70. So you'll note here that the only thing that's different is the 95 and the 15. So if you're a little bit crafty, you can just hit second enter in your graphing calculator and just cursor over to that 15, or excuse me, that 95, which we're going to change into 15, and just hit enter. And we get about 6.1. I like to look at this triangle to see if this makes sense. Smallest angle is here. The side opposite is also the smallest. The middle angle is here, and 22 is in between 6.1 and 23.3. And then we've got 95 degrees here across from the largest side. And that does make sense. And even the 6.1 is a lot lower than 22 or 23.3 because the angle is so small. So you could even reason a little bit further there and say that this side should probably be around that value, should be quite a bit less than 22 or 23.3. When we write our solution for this, we want to write what the angle that we didn't get or that we didn't have to begin with. So that's going to be angle P. So the measure of angle P will be about, 70 degrees. And then we also have sides D and A. So D is about or approximately 23.3. and A is approximately 6.1. All finished.